I have come to understand that statistics forms a very strong backbone of data science. Actually, I would say data science and all forms of analytics are all children of statistics. Now, today I'll be taking you through what we call statistics for data science and business analytics. I believe that day-to-day decisions ought to be guided by facts and figures. There has to be some kind of justification behind any reason that we make. So let's just dive into the field, into the presentation. It's a very short, simple presentation, because I understand that most of you are actually not from this field. It is something that is very simple to understand, and I hope as we continue with the presentation, you will present your comments. Where you don't understand, you can just type in and I can easily repeat. Now, at the end of this webinar, you'll be able to get an overview of data science, as the basic definition of what it is, business analytics, and how the two are brought together or linked to statistics, the types of data, the levels of measurements for the data, and then we will dig deeper into what we call predictive modeling. And in predictive modeling, today we'll be looking specifically at regression analysis, and then at the tail end we will see some of its applications. Good. Okay. How many of you before have come across this term statistics? You can type yes if you have. Good. I see that actually all of you have come across what we call statistics. Simply put, statistics is a branch of applied mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. Statistics is also the mathematical study of likelihood and probability of events occurring based on non-quantitative data or a collection of data. Today, let's look at this term, likelihood and probability. In the normal world, these two terms are the same. But now, when you start looking at it statistically, probability is simply the chance of something happening, right? Like the chance of, I love using this example of it raining tomorrow, because where I live, it really rains a lot. Probability is simply the chance of an event happening, like the event you are interested in, whether it's a pass or a fail, a success or a failure. But likelihood, in defining a likelihood, we have to look at two things. We have prior evidence and posterior evidence. Like there is the evidence that is there before and after. Like it is prior and posterior evidence-based statistics. That is the main difference between those two. Now, let's go to the next thing. Statistics does attempts to infer the properties of a large collection of data from inspection of a sample of the collection, thereby allowing educated guesses to be made with minimum expense. Like when we are dealing with very large sets of data, when it becomes paramount that we have to get large sets of data, like during the population census, we don't have to conduct a population census every year. Therefore, statistics comes in that we can use a small sample and be able to tell or get insights from the whole population. That is just but some of the definitions. Now we go to data science. It is a broad field that refers to the collective process, theories, concepts, tools, and technologies that enable the review, analysis, and extraction of valuable knowledge and information from raw data. I want us to maybe read between the lines here. We have the concepts, we have the tools, we have the technologies. Now here, you see that we have these three terms, the concepts here are the concepts that come from the main fields, that is mathematics, statistics, computer science, and your field of application, be it in engineering, be it in management. And then we have the tools. These are probably the programming languages or the database management programs that you have. They could be SQL, they could be R, they could be Python, could be SAS, could be whatever. And then we have the technology. So you can see that actually data science is not all about coding. You have to understand what you are coding. And today I was reading a very interesting article from Tech Republic. It was saying that 85% of all big data projects fail. Why? Because data science is a little bit misunderstood. We do not really combine all these aspects of data science. However, it is geared towards helping individuals and organizations make better decisions from stored, consumed, and managed data. Now, it enables us to use the theoretical, mathematical, computational, and other practical methods to study and evaluate data. Key objective is to extract required or valuable information that may be used for multiple purposes, such as decision making, product development, trend analysis, and forecasting. Well, simple example, look at the trend analysis. Like I believe the guys at Safaricom can easily tell, they can come up with targeted ads to their subscribers on a product like Skiza. If you see that the consumers are easily subscribing to something, then you can easily tell where to target your ads to. And equally in forecasting, this is very simple. You can simply predict your sales based on historical data, and then you use the various methodologies within your marketing experience to actually tell what product you need to develop more and which product to drop. Now, business analysis is simply just the research discipline of identifying business needs and determining solutions to business problems. Solution often include software system development component, but may also consist of a process of improvement, organizational change, strategic planning, and policy development. Now, when it comes to these business analysis, since I come from a public kind of background, with my short experience that I worked in my place of work, it is very easy to tell that government rarely takes the business analysis seriously, because actually government ain't business. So if only the people use this business analysis or the insights developed from these analytics, it can be so easy to make perfect decision. Look at the current drought situation. Like the government ought to have predicted this long ago, then come up with mitigation measures of preventing deaths or suffering by people due to hunger. Now, let us see how statistics and data science combine. Statistics can be a powerful tool when performing the art of data science. Basically, like visualizations. I have a simple visualization that I saw. Among the simplest is a simple budget. It can give you some very high level information, but with statistics, we can get to operate on the data on a much more information driven and targeted way. Like look at the classical example of looking at a bar chart and being able to tell the skewness or maybe the kurtosis of the data, and you can easily tell the median, you can tell the distribution of maybe the variables you are looking into. The math involved help us form concrete solutions about our data other than guesstimating. Simply, as I was saying, guesstimating. In the current world of business, it is almost suicidal to do guesstimating. Guesstimating is just coming up with kind of part truth and part lies. Are you with me? If you are with me, still, you can just type something. If you're with me, just type something. Cool. Now, when we're coming up with inferences, we always have large data sets. We have several variables that we are looking at. So let's look at the data types. Data types are an important concept of statistics, which needs to be understood to correctly apply statistical measurements to your data, and therefore to correctly conclude certain assumptions about it. We need to understand these various data types. Now, what are these data types? What are the data types that we are dealing with here? Now, we have categorical data and numerical data. Categorical data has two types. It can either be nominal or ordinal. Numerical data can either be interval or ratio. Now, let me look into each of these measures of scale for the data. Nominal data is simply string data, string like text. This is where the sentimental, you can do some sentimental analysis. You can try and extract data from string data. Ordinal data, just as the name says, it is data that is in orders. Maybe it can be ascending or descending, moving from one level to another. Interval data is similar to ordinal data in that, but in this case, in interval data, the distance between the two kinds of data groups that you are analyzing is measurable. And then we have ratio. Ratio is the highest form, the highest measure. It is actually similar to interval, but in this case, we have what we call an absolute zero. Like, it is like on a, we can simply put it's like on a number line. Now, let's look at this categorical data. As we had said, categorical data can either be ordinal or nominal. Now, look at these examples. Race, we have African, Caucasian, Asian, etc. Would someone type kind of data, what kind of measure of scale is this? Is it ordinal? Is it nominal? Just type in so that I see if you're still with me. Okay. I'd be biased. I'd be biased to say that this is actually nominal data, because in this case we are simply looking at the different kinds of races. There is no race greater than the other. This is simply string data. So this is actually nominal data. Equally, male and female, male, female, it is nominal. And then job group, entry level, mid level to senior. There we would see that there is some kind of order. This is ordinal. And then default status, if you have defaulted in maybe some facility or loan, we have this is in two groups, default or no default. Can you type in what you think default status falls into? Is it ordinal or nominal? Okay, now when it comes to defaulting, it's either you default or you don't default. In this case, this is still ordinal. This is still nominal data, sorry. This is nominal data. Ordinal data in this case is this, the level of education. We have primary, post-primary, etc. So in this case, you can see that there's some kind of order. Like you move from primary as you go to post-primary, as you go to tertiary. So in that case, we can see how the levels are transiting from one to another. Now, let's look at the numerical data. Quantitative data is a numerical measurement expressed not by means of a natural language description, as we had said there earlier. We have just either you're male or female, either you default or you don't default, but rather in terms of numbers. These data have meanings as a measurement, such as a person's salary, a net worth, the IQ, the blood pressure, speed of a moving vehicle, maybe the profits of a company, maybe the proceeds that someone makes from investment. This is continuous data. Like it can take any figure, any positive figure. It can be in the millions or it can be as low as 1. And then we have count data, such as the number of stock, the shares a person owns, how many tip, how many pages you can read in your data science book. I love using data science because I'm a big fan. This is discrete data. It can't take decimal values. Are you with me? Now, let's go to the next. We are now going deeper. Now, we have already got the types of data. Now, with this data, how are we going to use it to make predictions, kind of predictive analytics? Now, predictive analytics is a form of advanced analytics that uses both new and historical data to focus activity, behavior, and trends. As I want you to draw attention to these, both new and historical. Now, historical data is what we will call prior data. It takes some kind of a prior distribution. And then new data, in this case, we are looking at something that is coming. This is data that is generated daily or on an hourly basis. It involves statistical analysis techniques, analytical queries, and automated machine learning algorithms to datasets to create predictive models that place a numerical value or score on the likelihood of a particular event happening. Now, look at this. If you can remember, we were dealing with prior data, that is new, historical, and posterior data, which is new data. That's why we are dealing with likelihood of a particular event happening. Now, in predictive analytics, we have regression. And the simplest form of regression there is simple linear regression. In linear regression, we just construct a model, which is like an equation based on our data that we already have, right? We can then use this model to predict other variables based on the variables that we have. The variables we are making predictions about are called dependent variables. Commonly, that's what when drawing a curve or a graph, we always call it the y. In other cases, you can find it being called the response variable, the criterion variable, among others. As in, it is dependent. It is dependent because its outcome is determined by other variables. Now, the response variable is a similar term that can be used to it, but it is more often used, at least in the articles or the journals that I have read and published. It is the one that is most commonly used. However, the variable that we are using to make these predictions is called the independent variable. This is what we always call the x variable. It can also be called the explanatory variable or the predictor variable. It actually the predictor variable actually predicts the dependent variable. That's why it's called predictive. Now, linear regression is used for finding linear relationships between target and one or more predictors. There are two types of linear regression. We have simple and multiple. Simple regression is useful for finding relationship between two continuous variables. Like you can try and investigate the relationship between your age and probably something like your income, or probably look at a company's profile. You can see, for instance, let's look at Safaricom for instance. It's been in the market for quite a number of years, probably 19 or 20 years. And over the years, we can easily tell that their income has been increasing. So it is used to find relationship between two continuous variables. In that case, age, it is just calculated to days, it's actually continuous. And then income, or the net profit, is also continuous. So you can see that by putting age to be something that will predict the income, it is something that makes sense. Are we together? If we are still together, just type something, even if it's just typing the word something. Now, this kind of regression, it looks for a statistical relationship, not a deterministic relationship. Now, a relationship between two variables is said to be deterministic if one variable can be accurately expressed by the other. For instance, using temperature in Celsius, we people from Kenya, we use the Celsius, and people from the West use Fahrenheit. This is actually a deterministic kind of relationship. But with a deterministic relationship, it is, if you do some kind of correlation analysis, the correlation analysis will give you the correlation between the two be perfect. It will be always at 1. Statistical relationship is not accurate in determining the relationship between two variables. As you can see, the deterministic is like already predetermined. There's some kind of transformation applied to whatever you're predicting from the the item that you're using to predict. The core idea is to obtain a line that best fits the data. I'm sure most of you have heard something called the line of best fit. The line of best fit is just the trend line. But this line, it can pass through, if you draw some kind of scatter plot, this line can pass through all the data points. That is like a perfect fit. It can pass through most of the data points, and it also can pass through none of the data points. In that, the prediction error there is kind of constant. Now, the best fit line is one for which the prediction error is as small as possible, where we know that the prediction error is the distance between the points and the regression line, where the regression line is the line of perfect fit. Now, we're still here. A linear regression model follows a very particular form. In statistics, a linear regression model is linear when all terms in the model are the following. We have a constant, and then we have a parameter multiplied by an independent variable. Then you build the equation by only adding the terms together. These rules limit the formula to just one type. We have the y, and then we have the constant, and then we have whatever parameters there. Where I've labeled IV, it is the kind of coefficient. Now, not in all cases do we come across data that is continuous, either the independent or the dependent variable. Like, it's not all the time that we come across data like this, such as age versus the income. Now, suppose we have the following data. it will be easier to predict that as age increases, salary increases. Therefore, a simple linear regression can be done to predict the income of someone, say, who is 53 also. It is actually almost predictable because you can see that at 25, the salary is 85. At 35, it's 125. At 45, it is, you can easily see that is something that is, the trend is as age goes up, salary equally goes up. Now, why can't we use this all the time? The relationship between the age and the salary that we have seen here is linear. But suppose we have data which is binary, like we have gender against, suppose here now, instead of age, we have gender. And you know gender can either be male or female. Now what do we do in that case? We cannot simply just decide to go to linear regression, because you know data occurring in zeros and ones, again, let's say 0. This is data that is equally nonlinear. What do we do in that case? We have to kind of upgrade to another model. Now let's go to the nonlinear regression. During predictive modeling, we encounter data that has categorical response variables. Like people from the HR department, when you are doing headhunting, and then people send in their applications, you can easily tell, you can do some kind of analysis and tell the qualifications of those who are shortlisted against those who are not shortlisted. Equally in HR, you can do an analysis on those who are promoted and those who are not promoted. And for the banking industry and the credit listing, we have people who are in default and people who are not in default. And you know, the list can go on and on, but you can see that this is dichotomous data. It is either a success or a failure. It's either a success or a failure, and the list can go on and on and on. Now, this brings us to what we call logistic regression. Logistic regression occurs when we are dealing with data that the response variable, the response, that is the dependent variable, the y, is dichotomous. Like we either observe a success or a failure. It's either a 1 or a 0, a yes or a no. Now when it comes to that kind of data, we have to adopt a model called logistic regression. Now, what is this logistic regression? It is one of the basic and popular algorithm to solve a classification problem. Now, look at this classification. This is almost like the backbone of data science. Classification, like the most advanced levels of AI and machine learning, like in identifying photos. Like it will easily be used to classify if it is or it is not. So it is named logistic regression because its underlying technique is the same as linear regression. The term logistic is taken from the logit function that is used in this classification. Now, we identify problem as classification problem when independent variables are continuous. These are the x's. And the dependent variable is categorical. It is in classes. Like we can try to, in the coming census, I know they will be doing some kind of categorical data analysis when profiling Kenyans on maybe their counties of residence, maybe on their ethnicity. So in this case, they will most likely use logistic regression. A real life example of such classification will be spam. I'm sure most of you know what spam is. The emails that come in which are actually not needed or not spam. To categorize a tumor as malignant, that is cancerous, and benign, which is non-cancerous, and to put a transaction either to be known as fraudulent or genuine. like the M-Pesa, kind of M-Pesa reversals, or maybe the M-Pesa transactions. You can easily tell that maybe a claim by the agent or the customer. You can come up with a predictive model to predict if one of the two transactions, okay, if the transaction is either fraudulent or genuine. All these problems to be answered, they are all in categorical form, either yes or no. Now, there are very important points to mark about this logistic regression. It is used for classification problems only. And then logistic regression doesn't require a linear relationship between the dependent and the independent variables. It can handle various types of relationship because it applies an nonlinear log transformation. I think in the next webinar, or if at all we'll meet for face-to-face, probably after Easter, I will show you how we will apply this nonlinear log transformation to the predicted odds ratio. And then to avoid overfitting, I'll also show you this, and underfitting. We should include all significant variables. A good approach to ensure this practice is to use a stepwise method to estimate the logistic regression. Now, maybe I've gone too fast. So far, are we together? If we are together, just type something. I can repeat. Cool. Now, similarly, the logistic regression requires a large sample size because maximum likelihood estimates are less powerful at low sample sizes than ordinary least squares. OLS is simply the simple linear regression. Now, in our next webinar too, we will look into this maximum likelihood and the power of a test. This is what we call the estimation, the theory of estimation, like how we develop hypotheses and how we measure these the estimates. Independent variables should not be correlated with each other. There is non-multicollinearity. I'll also explain this in the next webinar. However, we have the option to include interaction effects of categorical data, the categorical variables in the analysis and in the model. If the variables of dependent variable is ordinal, then we have an ordinal logistic regression. And if the dependent variable is multi-class, then you have multinomial logistic regression. Like, you can easily see that this is purely categorical data that we are dealing in when handling logistic regression, because you can easily see that this is ordinal data and this is nominal data. Are we together so far? Maybe just as I conclude, we have these applications. We have marketing. Like, a marketing consultant wants to predict if the subsidiary of his company will make profits or losses, or just to break even, depending on the characteristics of the subsidiary operations. In this case, we'll just have to use logistic regression, because here we'll be comparing a profit, a loss, or maybe breaking even. So there, we will have what we call a multinomial. These are three. You're trying to your outcomes are going to be three. And then now we'll use the various variables to predict if they will make a profit, a loss, or maybe they'll just break even. However, in HR, the HR manager of a company wants to predict the absenteeism pattern of his employees based on their individual characteristics. This is also very interesting because you cannot be, it's either you are absent or present. There is no in between. This is also very interesting. You can analyze these using logistic regression. And then in finance, a bank wants to predict if his customer would default based on their previous transaction and history. Very interesting, eh? Safaricom introduced a new product called Fuliza, which I believe, not that I'm so sure of that, I believe that it was developed using the historical data for the customers. Like if your daily transactions are, let's say, 30,000 shillings, what will be your Fuliza limit? And you know, Fuliza is some kind of overdraft. So they would use this kind of model to predict if you can kind of default, or if you are a high-risk client or a good person in paying back their loans. Now, after all these, we have to appreciate the key concept of statistics in data science. Today, as I told you earlier, I was reading through various blogs, and it was a surprise that 85% of all data science models, all the predictive models, all the big data analytics, all the results that come from there, 85% of these projects actually fail. Why? Because we do not put in together all the key aspects that are required in data science. To be a data scientist is more than just statistics. It is just more than your background in finance. It is more than your background in computer science and coding and understanding the databases. It is a multidisciplinary field that has a lot of potential. And if we take data science seriously, we can actually improve our places of work, and our profits or our performance will actually be awesome. Now, my main emphasis is data science is all about passion. You should read widely. Now, for practicals, we will be using, I prefer R for this because it's something that I have taken so many years to learn, and it is something that I'm very comfortable with. But however, I'm sharing some links on Python in doing the kind of regression analysis, either logistic or simple linear regression. There is this book by O'Reilly, Practical Statistics for Data Scientists. It goes on Amazon for around $100. You can just maybe spare some little cash and maybe buy it. It's a very good, insightful book. And there are also several books. Maybe I can share them. And then there are these links on doing the regression using R. There's that link by R, by the R Studio. And then there's also the logistic regression link. You can just follow those links and see how there are some kind of tutorials, how they were done in R. And then in Python, we have one that was done on GitHub. That is the link. And also for logistic regression, also in Python, we have this done on GitHub. You can actually go through them and try to conceptualize whichever programming language you're comfortable with. I know there are some who are just okay with Excel. It is also something that is very easily done in MS Excel. And we also have SPSS, we have Stata, we have SAS. They are all done there. Those are the online resources. And however, I wanted to show you some kind of directory for large sets of data. It is a directory by IBM, freely available. You don't have to pay anything. You just need probably to have SPSS installed in your laptop or computer, and then you can follow this link and you see how you can easily access these data sets. They are actually in the thousands. There are so many that they are all free that you can actually use for your analytics. Probably if you have any questions, you can ask them now, and I'll freely respond. Any questions? We will be having a one-on-one interactive session on this predictive modeling using regression analysis, probably after the Easter break. And I would really love to show you guys how powerful these predictive analytics using the regression models can be when coming up with when you're developing key decisions for your company or your place of work. Actually, as I've indicated here, the next interaction will be modeling basics using R. That is what I love to use. I see Dennis on the marketing example with 3 dependent variables. What does it mean? Will you have 3 equations, integration equations? Okay, let me get to that. Yeah, in marketing, profit, loss, or just breaking even. Now, in this case, we'll be dealing with the so I said it's multinomial kind of logistic regression. Now, in this case, we'll simply be having one model, one equation. We don't have to generate one for profits, again another one for loss, another one for breaking even. We'll just use one, and from there, I'll show you how we can come up with the best model. Maybe the variables that will be used in analyzing for profits will be different from the ones for analyzing loss and maybe for breaking even. For these, we will actually use maybe R. R will be okay, and we'll come up with the best model. We have something called they are models, but they are models which are better than other models based on some kind of some parameter. So on this, we'll actually do a practical, and I will show you how you can come up with the best model with it. Are we okay with that, Dennis? See, Catherine is typing. I think, oh yeah, sorry, I think we're back. Now, where was the question? There was a question by Dennis. The data set being worked on in HR, what if it is not marked clear, present, or absent? Now, the funny thing about logistic regression, when you are actually looking for a specific kind of outcome, whether the person was present or absent, by default, we will assume all the missing values. All the missing values, the whole, maybe if you're doing, if the data is in raw or not, we'll assume the whole data set where the present or absent kind of variable is missing. Equally, in finance, the bank does not show default versus not defaulted. Now, in this case, equally, we'll assume that kind of the data for that specific client. We'll only analyze on the data that has the response variable present. However, missing data is a very big can of worms. There are ways that this missing data can be filled in, but not when dealing with logistic regression. Missing data can be fitted in when you're dealing with linear regression, but not logistic regression. I hope you're getting me. And then, Waruiru, can linear regression model be used to predict stock market prices or trade in forex? Exactly. Now, like when a product has been making, like let's look at a company like Safaricom. If Safaricom has been making profits all through, and you can easily see that these profits have been all through the years, the turnover has been, let's say, positive. You can easily tell that, you can easily predict. However, when also predicting this, you can use the linear regression model. It all depends on the kind of data that you have in stock. If it is simply profit loss, you can use that. But if it is continuous data, you can easily tell that yesterday's price for the stocks was maybe 19 shillings per unit, and maybe tomorrow, maybe the other day it was 21 shillings per unit. You can easily tell the trend. So in this case, if you are dealing with continuous data, either on the y variable or the x, okay, mainly on the y variable, you can easily use the linear regression model. But when you're dealing with simple profit and loss, you only have to deal with logistic regression. Equally in trade for Forex, it depends on how you look at it. If it is the Kenyan shilling against the US dollar, and today the Kenyan shilling had a dip, if you're looking at binomial data that is having a dip or having some kind of surge, it will all depend on the kind of data that you have in that case. But when you're dealing with actual numbers, like today, let's say the dollar is at 101, and the day before yesterday it was at 102, there in that case you will use the linear regression model and not the logistic regression model. Now I see linear regression model. Yeah, linear regression model can be used in predicting the stock market prices and the trade in Forex. It all depends on the kind of data that you have. The data that you have is what that will predict the kind of regression model that you have to use. Again, there was some question on the churn rate. Yeah, by cutting. Yeah, equally churn rate, the customer churn rate can equally be modeled using logistic regression. That's what I'm saying. All this, it all depends on the data that you have in the response variable. Because if it is categorical data, you are only limited to use the generalized models, that is the logistic regression, among others that I will introduce to you over time. However, if the variable on the dependent, that is on the y, if it is something that is continuous, and maybe what you are investigating is maybe the y variable that you're investigating is continuous, and the other variables are equally continuous or non-continuous, you will have to use the simple linear regression. But if it is categorical, that is, if the y variable or the dependent variable is categorical in any way, you are limited to using logistic regression, or maybe at a later time I'll introduce you to something called discriminant analysis. It is some high-level form of logistic regression. They're kind of related, but it is slightly different. Yeah, I think. Any other questions? Any other questions there? Well, I would love to hand over the session back to the organizer, Kevin. Probably, I think we are done for today. I will share more data sets on Slack, and the links will also be shared on Slack.